Namaskar students, today we are going to study about surface chemistry. Surface chemistry is a branch of chemistry which deals with the phenomenon that takes place on the surface. Or interface. We can say interface is a boundary that separates the two bulk faces. So gases form a homogeneous mixture. They cannot form boundary or interface cannot be formed between the gases. So this can be excluded from the surface chemistry because gases form a homogeneous mixture. Gases do not form interface because they forms a homogeneous mixture. So some common terminology that is used in surface chemistry. Adsorption. Adsorption, this term can be related to a solution also, because as solution, binary solutions, they are composed of with solute and solvent. So adsorption is the phenomenon of accumulation of a substance on the surface. So it is divided into two parts: adsorbate and adsorbent. Adsorbate is the substance that get adsorbed on the surface, which gets adsorbed, and adsorbent, site on which adsorption occurs. This is where substance which get adsorbed is known as adsorbate, and the site where adsorption occurs is known as adsorbent. So adsorption is a branch of science, a branch of chemistry. We can say that it is the accumulation of the substance which is on the surface or interface. Interface is a boundary that separates the two faces, which comprised of adsorbate and adsorbent. Adsorbate which get adsorbed, and adsorbent, it is the site where adsorption occurs. So when we can say sorption. Sorption is a term which is used because this adsorption term can be related with absorption also. Absorption is the process of accumulation of substance in the bulk. That is absorption. Accumulation in the bulk. So when absorption and adsorption both occur simultaneously, then it is known as sorption. When both adsorption and absorption occurs, then we can say that it is known as sorption. Now the desorption. The process of removal of the adsorbed layer is known as desorption. The process of removal of the adsorbed layer is known as desorption. Now we will going to discuss about some of the evidences that support adsorption. First, when methylene blue dye is shaken with animal charcoal, then its color fades away. It means the colored components of the dye are adsorbed on the surface of the charcoal. For example, in our day-to-day life, we can see that when we purchase some of the items, for example, electronic items or shoes, bags, then some small ball-like materials are kept in the bags or shoes because those balls are silica gel. So silica gel adsorbs moisture. That is why silica gel packets are kept in these substances because they absorb moisture, because moisture creates a specific characteristic smell in those substances, because those substances are maybe packed for long period of time. So silica gel is kept because it absorbs moisture. Raw sugar. Raw sugar is yellowish in color. So when it is shaken with charcoal, then it becomes colorless. That is, it can be filtered and on crystallization colorless crystals are obtained. So what does it indicate? That the impurities are adsorbed by the charcoal. Now solids like platinum, palladium, nickel, etc. These solids are used in hydrogenation process with hydrogen gas. So this hydrogen gas gets adsorbed on the free valencies. It binds with the free valencies of metals. So these are the most common examples which we generally study in chemistry in somehow different chapters. So these are the evidences that supports that this adsorption is the process that takes place on the surface. Now we can suppose that this adsorption term, it is clear in your minds. Now adsorption is a process. Adsorption is a exothermic process. Exothermic process means after adsorption, it lowers down the surface energy. Which indicates is released during the process. Hence we can say that adsorption process is an exothermic process. The enthalpy change during the process will be negative because heat is released during the process. Now whether the adsorption process will occur or not, that can be decided from Gibbs-Helmholtz equation. Delta G equals to delta H minus T delta S. Adsorption process may be whatever kind, it may be chemical adsorption or physical adsorption. Physical adsorption we will going to study it later on, because in physical adsorption, physical changes generally it occurs in processes which involves physical changes and chemical reactions, chemical adsorption. So delta G equals to delta H minus T delta S. Delta G is the change in Gibbs free energy. Delta H is the enthalpy change and delta S is the entropy change, and T is the absolute temperature. Absolute temperature. So delta H, as sign of delta H is already negative because it is an exothermic process. So for the adsorption process to be spontaneous, delta G should be negative. It should be negative for adsorption to occur. So now what we can say about the entropy change? Entropy is the measure of degree of disorderness or randomness of the system. So when any substance get adsorbed on the surface, then what we can say about the entropy change? Entropy change means the final disorderness or randomness has been decreased, and initial disorderness or randomness was more. So the final decreased and initial was more. So what will be the change? Change in sign will be negative. So negative will be negative into negative. That makes the entire positive because the absolute temperature will be always in positive. So this factor is positive and delta H is negative. So this negative factor must be more for the process of adsorption process to occur spontaneously, or for the process to become feasible. Delta G should be negative. So this is the mechanism, thermodynamic mechanism that is related to the adsorption process. Now as we have already discussed about absorption and adsorption, so what are all the differences between the adsorption and absorption process? Adsorption and absorption. Adsorption is the process of accumulation of substance on the surface, and absorption is the process of accumulation of substance in the bulk. Adsorption, initially it is a fast process. After equilibrium attained, process becomes slow, and absorption process occurs at uniform rate. This we can say that adsorption is a surface phenomenon and absorption is a bulk phenomenon. Now how adsorption can be related with the, how it is a surface phenomenon. Surface phenomenon means, for example, we consider one liquid this liquid, and here are these are the vapors of the liquid. So the molecule which is present inside the liquid, that is equally attracted or repelled in different directions. So net resultant force on the substance which is inside the liquid is zero, and the molecule which are present on the surface, that is attracted by the vapors also, vapors of the liquid, as well as by the liquid molecules which are present inside the liquid. So the force of attraction on the particles which are present on the surface is more as by the liquid molecules present inside as compared to the vapors of that liquid. So that is why these molecules is attracted inwards, and it creates a surface tension. Attracted inwards, that is why this is a surface phenomenon. By this we can explain that it is a surface phenomenon. Now, these are the basic differences between adsorption and absorption. Now this adsorption is of two types. Adsorption in solutions. Adsorption in solutions, we can study two components in solutions, mainly solute and solvent. One solute, for if mostly usually in adsorption phenomenon, solute particles get adsorbed. So if the concentration, so the concentration of the solute particles, that may be inside the bulk also. So if concentration is more on the surface, for example, any particles which from the solution are adsorbed, then if the solute particles are adsorbed, then their concentration on the surface increases. If concentration is more on the surface as compared to bulk, then it is known as positive adsorption. If concentration is less on the surface as compared to bulk, for example, our blood charcoal. Blood is blood composed of blood, sugar, and different type of salts are also present in blood. So when blood charcoal is formed and concentrated KCl solution shaken with blood charcoal. When concentrated KCl solution is shaken with blood charcoal, then it shows positive adsorption, and when dilute solution of KCl is shaken with blood charcoal, then it shows it respect to negative adsorption. So these are the basic differences between adsorption and absorption. Now we can recall what are the terms in which we have studied in this during this period of teaching. Adsorption is the branch of science that deals with the study of the process phenomenon that taking place on the surface or interface. Interface is a boundary that separates the two bulk phases. Now adsorption is the basic terminology that is used in adsorption is adsorbate. The substance which get adsorbed is known as adsorbate, and the site, for example, oxygen molecules are adsorbed on this surface of this duster. Then we can say that oxygen molecules are adsorbate and this duster, because this is a site where adsorption is taking place. So this is known as adsorbent. So for example, the process, one term which we have used is desorption. Desorption means the process of removal of the adsorbed layer. So how adsorbed layer can be removed? For example, here temperature is raised. So when temperature is raised, then the concentration of the oxygen molecules on the surface of this duster will decrease. Or by changing pressure, we can also change the concentration of the adsorbed substances. So that desorption process can be carried out either by change in pressure or by change in temperature. Now, absorption. Absorption means the process of accumulation of the substance on the bulk inside and adsorption on the surface. So, adsorption is the surface phenomenon and absorption is a bulk phenomenon. Now, adsorption occurs at, initially it is fast in the beginning, and then when equilibrium is attained, then it becomes slow. While absorption always occurs at uniform rate. And how, so for adsorption process, whether it is physical adsorption or chemical adsorption, it will be always exothermic, because as adsorption involves the formation of new interactions. So when new interactions are formed, then the surface energy gets lowered because heat is evolved during the process. Hence it will be a exothermic process. Now adsorption from solutions. When the concentration of solute on the surface is more as compared to the bulk, then it is known as positive adsorption. And when concentration of the solute is less as compared to the bulk, then it is known as negative adsorption. That we can study in terms of our blood charcoal. As blood is composed of different type of salts, so when KCl is taken with blood charcoal, then it is positive adsorption. And when dilute solution of KCl is taken with blood charcoal, then it is a kind of negative adsorption. And as it is a surface phenomenon, that can be shown in terms of surface tension, because the particles which are present at the surface, they are attracted always inwards, and the particles which are present inside the surface, they are equally attracted or repelled in all the directions. So force of attraction on the particles which are present on the surface is more as compared to the particles present inside, compared to the particles which are outside, because outside particles exert less forces as compared to the inner particles. That is why the particles is equally attracted inwards. So now we are going to study about the factors affecting adsorption of gases on solids. Factors affecting adsorption of gases on solids. Sorry. First, nature of adsorbate and surface area. Here adsorbate are gases and adsorbent is solid, because solids provide the site where adsorption will occur. So nature of adsorbate and surface area. Surface area and nature of adsorbent, these are two factors. So gases which are easily liquefiable are gases which are easily liquefiable are more easily adsorbed. So how we can study this, how we can say that gases are easily liquefiable, that we have already studied in states of matter in class 11th. That depends on the critical temperature of a gas. Critical temperature, it is the maximum temperature above which the gas cannot be liquefied. It is the maximum temperature above which gas cannot be liquefied, whatever high may be the pressure. So higher, we can say higher is the value of critical temperature. Critical temperature is represented by Tc. So higher is the value of Tc, more easily gas can be liquefied. Higher is the value of Tc, more easily the gas can be liquefied. What does it indicate? That means the gas will be more easily adsorbed. For example, hydrogen, nitrogen, carbon monoxide, methane, CO2, HCl, ammonia, SO2. So this is the increasing order of Tc. Hence we can say that ease of liquefaction increases. So as the ease of liquefaction increases, so ease of adsorption increases. So from this we can predict that higher is the value of critical temperature, more easily the gas will be liquefied. If the more easily the gas will be liquefied, more easily it will be adsorbed. So we can say that this is about the nature of adsorption. Means it depends on the critical temperature of the gas. More easily the gas can be liquefied, more easily it will be adsorbed. And why among these gases we can say that sulfur dioxide is more easily adsorbed? Because its dipole moment value of is high. That is why these gases are easily liquefied. Even sulfur dioxide gas vapors, they can be formed in laboratory. Hence its extent of adsorption will be high. Now second, temperature. For example, here is a solid plus gas. So this gas has to be adsorbed on the surface of the solid. So what process you have to follow? The process we have to follow is condensation. So here gas is adsorbed on the surface of the solid gas plus energy. Energy is given out. Means adsorption is exothermic in nature. Now if temperature is raised, then it leads to the process of evaporation. Means it will be adsorbed. As we have earlier, as we have discussed, the temperature and pressure, these are the two factors by which we can accompany the process of desorption. Means the process can be, the two phenomena can be removed. And so condensation and evaporation. When temperature is lower down, then we can bring about the process of adsorption. And when temperature is increased, then the particles will get evaporate out and it will be separated out, and this phenomenon is known as desorption. So this is the main role of temperature. Then in detail we will discuss it after the physical and chemical adsorption. Because as the generally if we see, then we can say that with the rise in temperature, as adsorption process is delta H is negative. So according to Le-Chatelier's principle, the extent of adsorption should decrease with rise in temperature. But it is not exactly in both kind of adsorption, because in physical adsorption involves the only formation of physical interactions, while in chemical adsorption initially some amount of energy has to be required. That is why initially the extent of adsorption increases with rise in temperature and then decreases. That we will later on discuss in physical and chemical adsorption process. Now third, pressure. What will be the effect of pressure? So if pressure is increased, then extent of increases. Here temperature should be constant. Amount of gas adsorbed, and here pressure. See, T1, T2, T3, T4. These are the different temperatures, different constant temperatures where we can study the amount of gas absorbed. For example, here in first case, this range of pressure is very small. Range of P is less, but the amount of gas adsorbed is very high. So we can say that value of T1 is very less. So T1 is less than T2, less than T3, T4. Means as temperature rises, then pressure has to be increased to a very great value, and if temperature is lower, then within a short range of pressure, the amount of gas adsorbed will be very high. So overall, what we can conclude that if P increases, then the extent of pressure increases, then the extent of adsorption increases. Now fourth, surface area. Surface area is directly proportional to the extent of adsorption. We can say higher is the surface area, more will be the extent of adsorption. Fifth, activation of adsorbent. Activation of adsorbent means if the adsorbent is activated, then the extent of adsorption in that case increases. And how activation can be done? Activation can be done by making the surface more rough. By making the surface more rough. This we can study in our day-to-day life. Because for example, this is a plaster. In the plaster, the surface area is more. So in plaster, first of all, we apply wall putty. So why wall putty is applied? Because the pores, small pores that are present in the plaster, that gets filled with the wall putty. And after that, what occurs? After that, we use different kind of paints on the surface of the wall. So after applying wall putty, the surface becomes more plain, more smoother. Then the consumption of the paint will be less, and that will be economical for us. So if we have to increase the extent of adsorption, then we can make the surface more rough. Because during the process, when we use different kind of paints on the surface, windows, almirahs, and different doors, so then we use sandpaper and we rub the paint that was initially existing on the surface, and after that new paint solution is applied. So in that case, the extent of adsorption increases. So next, by heating it in superheated steam. What is in superheated steam? In superheated steam, the substances or the impurities that are already present, that get removed. By removal of gases, which are already adsorbed. So gases which are already adsorbed on the surface, we can remove those gases, then the extent of adsorption will also increase. So thank you. In next video, we will going to study the differences between physical and chemical adsorption.